Welcome to a new video class. In this video class, we are going to discuss the topic buffer. Actually, buffer is a solution which can able to maintain a constant pH. We know that our blood maintain a pH of 7.35 to 7.45 pH. This is the pH of our blood, is slightly alkaline or basic in nature. Daily we are eating and drinking different kind of food and different kind of juice, water, like that. All the minerals which are present in the food are then moved into our blood. Our blood carry all those energy producing substances and minerals into different tissues. But during that period, also our blood maintain a constant pH. The main reason behind the maintaining of this constant pH is due to the presence of a specific buffer in our blood. That buffer is called carbonic acid bicarbonate buffer. Carbonic acid bicarbonate buffer. So it shows the relevance of buffer in living organism. We know that living organism contain various kinds of enzyme and various kinds of enzymes, protein, etc. All those enzymes and protein maintain or perform its function at a constant pH. If the pH disrupt or if any changes occurs in the pH of any biological system, then that leads to inactivation of protein and enzyme. So in order to avoid such kind of incidents, all biological system contain a certain kind of buffer. That buffer maintains a specific pH within that system. So in our case, we need a specific buffer. That buffer is called carbonic acid bicarbonate buffer. So in simple terms, we can say that buffer is a mixture or a solution which can able to maintain a constant pH in a system. That is about buffer. And when we try to study the details of buffer, we can say that buffer are mainly categorized into two. One is called acidic buffer, and second one is called the basic buffer. So from the word itself, we can say that acidic buffer is a buffer solution. That buffer possesses a pH. That pH is below 7. That is why it is called acidic buffer. Like that, alkaline or basic buffer is a buffer solution which possesses a particular pH. That pH is below 7, not that pH is above 7. That is why it is called basic buffer. That is one of the difference between acidic and basic buffer. Second difference is that acidic buffer solution contain weak acid and a strong base. Acidic buffer contains a weak acid and one of its strong base. That is the concept. Let us take an example. Acetic acid sodium acetate buffer. Acetic acid, this is CH ratio, acetic acid and sodium acetate buffer. That is an example for acidic buffer because that buffer possesses a pH of 4.75. That is why it is called acidic buffer. And when we take the case, this acetic acid sodium acetate buffer, this acetic acid is a weak acid and sodium acetate is its salt, but it is strong. Then what is strong acid and weak acid. Acetic acid is a weak acid. The difference between strong acid and weak acid is that strong acid ionize completely in water when compared to weak acid. Weak acid ionizes little, whereas strong acid ionizes completely. That is the difference between strong acid and weak acid. So, when we take the case of basic buffer is a buffer which contains weak base and its strong salt or its strong acid. You can select one of its strong acid. That is called a weak base. That is called a basic buffer. Here, a strong acid, one of its weak. Here, weak acid and one of its strong base. Here, it is vice versa. That is the concept. Next, we will try to study the mechanism of buffering action. How a buffer solution maintains the pH of a given solution. Okay. Suppose, first of all, let us try to understand. This is the acetic acid present within this acidic buffer. Acetic acid is a weak acid. Even though it is a weak acid, it ionizes in water, gives rise to CH3COO minus, that is called acetate. That is called acetate. This is acetic acid. This is acetic. This is acetate. This is hydrogen ion proton. The concentration of hydrogen ion is considered as pH. pH is determined by the concentration of hydrogen ion and the concentration of OH minus ion. So here acetic acid dissociate into acetate and H+, but the dissociation rate is very low. So only few amount of acetic acid get dissociated, whereas all other acetic acid remains as such in an unionized form. Whereas sodium acetate, it is a strong, so it dissociates completely into acetate and sodium ion. So when we take this case, here the dissociation is very high, so we cannot able to see sodium acetate in a buffer because all those sodium acetate get ionized into acetate and sodium plus Na plus. But here we can see lot of acetic acid, but it is because it is a weak acid, so its dissociation is very low, but few amount get dissociated like this. So in a acetic acid sodium acetate buffer, we can see more number of sodium, more number of acetate which are coming from which comes from the dissociation of sodium acetate, and small amount comes from the dissociation of acetic acid. And like that we can see acetic acid in an unionized form, and like that we can see protons or H+, and we can also see sodium plus. But in this perspective we need H+, CH3COO minus, CH3COOH. So all those factors are present. That is the main component within an acetic acid sodium acetate buffer. Let us try to understand when we add an acid into the solution. Suppose if we add an acid into a solution containing this buffer, if we add an acid into a solution containing this buffer having all those contents, so this buffer maintain the pH of that solution even though we add an acid. We know that an acidic solution contains more number of H+, that is why it is called acid. So when we add an acid into a solution having this buffer, automatically that acid contains more number of H+. So that H+ ion react with CH3COO minus ions of the buffer present in the solution and converted into CH3COOH. So the acidic activity get neglected. So the solution of that pH remain constant as the previous. Even though we are adding an acid, that acid nature get destructed by the activity of CH3COO minus. So this is the example for buffering action. Suppose if we add OH, if we add alkali or base, if we add alkali or base, we are adding alkali or base, and that alkali contain more number of OH minus ion. That is why it is called base. So the addition of that base also doesn't change the pH of the given solution due to the presence of this buffer. How it will happen? We will study. This OH minus ion react with COOH. I already told you that COOH is a weak acid. It ionizes only little. So more amount of CH3COH will be remain as this. That CH3COH react with this OH minus ion. During the reaction, this OH minus ion react with this H and converted into water molecule. So the OH minus ion addition will be balanced by the activity of this COH. Okay, like that, another reaction can also possible here. The OH minus ion of the added base can also react with this H plus, creating water molecule. In this case also, the OH minus activity, basicity or alkalinity get neglected, get destructed or replaced or eliminated by the activity of this OH present in the buffer system. So here in this manner, the buffer can able to maintain a constant pH. But the main fact is that even though we are saying that the buffer can able to maintain a constant pH, there will be a slight change. Very slight change can happen in case of, even though the buffer system is present in a given solution, slight change may be happen. That is not a big change. That's why we are saying that buffer maintain a constant pH. Like that, when we take the case of basic buffer, the basic buffer is a buffer solution which contain a weak base. That is here NH3 and one of its salt NH4Cl. Here NH3 is a weak, so weak base. So when this NH3 react with the water molecule, it gives NH4 plus OH minus ion. But here the reaction rate is very low because it is a weak. Okay. But when we case the NH4Cl, it is a strong, it completely dissociates into NH4 plus Cl minus. This is the case of this basic buffer, and it also work like this, like an acidic buffer, by maintaining a constant pH. This is about the buffer action of all kind of biological material, and we have different kind of buffer. Here I already discussed so acetic acid and sodium acetate buffer, ammonia and ammonium chloride buffer only. Like that, we will discuss the case of bicarbonate and carbonic acid buffer. We have different kind of buffer like phosphate buffer, and we have different kind of buffer. And one more thing about the buffer is that buffer possesses a specific pH, and that buffer maintains the pH of other solution. The chemical nature of buffer can also be disturbed by using other agents. The buffer cannot able to maintain its pH constant. That pH may be vary due to the influence of some other external factors. Then during that condition, we can say that that buffer is not a proper working buffer. That's it. Okay.